The particle on a ring is a useful model for the motion of electrons around the porphyrin ring, the conjugated macrocycle that forms the structural basis of the Haeme group and the chlorophylls. The group may be modified as a circular ring of radius 440 picometers with 22 electrons in the conjugated system moving along its perimeter. In the ground state of the molecule, each state is occupied by 2 electrons. Calculate the energy and angular momentum of an electron in the highest occupied level. Calculate the frequency of radiation that can induce transition between the highest occupied and lowest unoccupied levels. There are 22 electrons in the conjugated system, which means there should be 11 pi bonds. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is in the form of a circular ring like this. So we can consider the motion of these pi electrons in the circular ring, and the radius is given as 440 picometers. Since there are 22 electrons involved in the conjugation, and there should be 22 divided by 2, which is 11 pi bonds. Because there are 11 pi bonds, (11 over 2 is 5.5, and when you rounding it down, you get 5. So we can say that the angular momentum states will have quantum numbers equal to m's of L being 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and plus or minus 5. Since each orbital can occupy 2 electrons, we can see that m's of L will have 2 electrons. When m's of L is plus 1, it will have 2 electrons. When m's of L is minus 1, it will have 2 electrons, so that would be 4. Again, when m's of L is plus 2, it will have 2 electrons. When m's of L is minus 2, it will have 2 electrons, so it will be 4. So 4 here again, 4 here, 4 here. If you add them up, we see that we account for 22 electrons. The energy required for transition would be the energy required for transition between the highest occupied angular momentum state, which is m's of L equal to plus or minus 5, to m's of L is equal to plus or minus 6, which is the lowest unoccupied state. So this is the highest occupied state, which is m's of L equal to plus or minus 5, and this is the lowest unoccupied state. Note that the energies in m's of L of plus 5 and m's of L of minus 5 is the same. They will be degenerate, and m's of L of plus 6 and m's of L of minus 6 will also be the same because they both are degenerate. So energy in m's of L of 5 is given by E equals L squared H cross squared by 2I, and I is equal to mr squared, where m is the mass and r is the radius. So to find out the energy and angular momentum of an electron in the highest occupied level, first let's find out the angular momentum at the highest occupied level. The angular momentum is given by J of Z is equal to m's of L H cross. In this case, the angular momentum of the highest occupied level is phi. So for the angular momentum quantum number of the highest occupied level is phi. That times H cross, which is 6.626 times 10 to the negative 34 joules second, over 2 pi, which is 2.314. That gives us 5.273 times 10 to the negative 34 joules second. So this is the angular momentum of the highest occupied level. Of the electron in the highest occupied level would be E is given by H cross squared L squared by 2I. So that is 6.626 times 10 to the negative 34 joules second over 2 times 3.14 square times 5 square over 2I, which is 2 times 5.273 times 10 to the negative 34 joules second. We get 7.88 times 10 to the negative 19 joules. For part B, calculate the frequency of radiation that can induce a transition between the highest occupied and lowest unoccupied levels. We have to find delta E between m's of L is equal to 6 plus or minus 6 and m's of L equal to plus or minus 5. So since E equals L squared H cross squared over 2I, we can say that delta E would be equal to those times m's of L final squared minus m's of L initial squared. So that would be H cross squared by 2I times 36 or 6 squared minus 5 squared. Plugging in the values, we get 3.46 times 10 to the negative 19 joules. The Bohr frequency associated with this delta E will be delta E is equal to H nu. So nu would be 3.46 times 10 to the negative 19 divided by 6.626 times 10 to the negative 34 joules second, which is 5.23 times 10 to the 14 per second.